Welcome to the session on trigonometric identities and equations. Equations and identities. The objectives for this session are to solve quadratic equations in sine theta, cos theta, or tan theta. Solving quadratic equations in sine theta, cos theta, or tan theta may give rise to two sets of solutions. So, for example, consider the equation 6 cos squared x minus cos x minus 2 equals 0. Factorizing gives us 2 cos x plus 1 times 3 cos x minus 2 equals 0. Then setting each factor equal to 0 gives either 2 cos x plus 1 equals 0 or 3 cos x minus 2 equals 0. Let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a first. Solve for theta in the interval 0 less than or equal to theta less than or equal to 360 degrees, the equation 10 cos squared theta minus 17 cos theta plus 3 equals 0. So let's solve this. Now 10 cos squared theta minus 17 cos theta plus 3 equals 0 implies 2 cos theta minus 3 times 5 cos theta minus 1 equals 0. Therefore, either cos theta equals 3 over 2 or cos theta equals 1 over 5. Now cos theta equals 3 over 2 has no solutions, since 3 over 2 is greater than 1, and the maximum for cos is 1. So we have to work with cos theta equals 1 over 5. If cos theta equals 1 over 5, the principal value is cos inverse of 1 over 5, which is equal to 78.5 degrees. Now, recall that cos is positive in the first and fourth quadrants, as you can see from the cast diagram. So cos of the angle is either in this quadrant, the first one, as you can see, or the fourth one. So theta equals 78.5 degrees, which is the principal value, or 281.5 degrees, which is 360 degrees minus 78.5 degrees. Now let's take a look at example 1b. Solve for theta in the interval the equation sine squared theta minus 45 degrees equals 1 over 4 for theta between 0 and 360 degrees. So let's solve this. Sine squared of theta minus 45 degrees equals 1 over 4 implies sine of theta minus 45 degrees equals plus or minus a half. So either it's plus a half or minus a half, as you can see. If it's plus a half, then theta minus 45 degrees equals 30 degrees. Sine is positive in the first and second quadrants. So here are the two solutions for this equation. 30 degrees in the first quadrant or 30 degrees in the second quadrant where sine is positive. But of course in the second quadrant we can't call it 30 degrees. Here's 30 degrees in the first quadrant And this 30 degrees here is actually 150 degrees in the second quadrant. In other words, 180 minus 30 degrees. Now let's find the other solutions. If sine theta minus 45 degrees equals minus a half, then theta minus 45 degrees equals minus 30 degrees. And sine, remember, is negative in the third and fourth quadrants. We can see this from the cast diagram. Therefore, theta minus 45 degrees equals 330 degrees, which is minus 30 degrees, as you can see, or 210 degrees, which represents this angle here, because sine is negative in this quadrant. And where does 210 degrees come from? It's 180 degrees plus 30 degrees. So the solutions are theta equals 75 degrees, 195 degrees, 375 degrees, and 255 degrees. Notice that we're only looking in the interval from 0 to 360 degrees. Therefore, we rule out 375 degrees because this is greater than 360. So in fact, theta equals 75, 195, or 255 degrees. This brings us to the end of this session. If you have understood its contents, you should be able to solve quadratic equations in sine theta, cos theta, or tan theta. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.